remember correctly, we had finished the one about the spiders on the previous page, correct? Thank you.
Yes.
Yeah.
All right, so let's take a look at this one. Again, this is one that I took from the AP Central website. So a national consumer agency selected independent random samples of 45 owners of newer cars less than 5 years old and 40 owners of older cars more than 5 years old to determine the difference in mean dollar cost of yearly routine maintenance, such as oil changes, tire rotations, filters, and wiper blades. The agency found the mean dollar cost per year for newer cars was $195 with a standard deviation of $46. For older cars, the mean was $286 with a standard deviation of $58. Which of the following represents the 95% confidence interval to estimate the difference, newer minus older, in the mean dollar cost of routine maintenance between newer and older cars? Okay, so the first thing to notice is that we're doing newer minus older. Okay, and that is frequently the way that we'll write those out. I usually don't write out the word minus. I usually do newer and the minus sign and then older. So we can eliminate some of these immediately. So for the newer cars, the mean dollar cost was $195, so it should start with $195. So these two are out immediately. Then we notice that the t statistic is all the same for the three that remain. In fact, as it was the same for all of them, so we don't have to mess with that. We just have to figure out, well, which one of these is the correct way to do the standard error. Do you remember which way is the correct way to do the standard error?
The first one.
Nope.
The third one.
Yep.
Yeah, this is restaurant.
Yes.
Why are B and C different?
Because on B it has it all over one denominator.
Why does it have to be separate again?
Because I mean that's the way the formula is. Remember.
Because you square them and then divide it?
Yep. Yep, you square and divide for both of them. Okay, let's move on. We're going to try to get through as much of this as we can. I don't think we're going to get through everything I want to get through today, but that's the way it goes. So, a serum cholesterol level above 250 milligrams per deciliter of blood is a risk factor for cardiovascular disease in humans. At a medical center in St. Louis, a study to test the effectiveness of a new cholesterol-lowering drug was conducted. 100 people with cholesterol levels between 250 milligrams per deciliter and 300 milligrams per deciliter were available for this study. 50 people were assigned at random to each of two treatment groups. One group received the standard cholesterol-lowering medication, and the other group received the new drug. After taking the drug for 3 weeks, the 50 subjects who received the standard treatment had a mean decrease in cholesterol level of 10 milligrams per deciliter with a standard deviation of 8 milligrams per deciliter, and the 50 subjects who received the new drug had a mean decrease of 18 milligrams per deciliter with a standard deviation of 12 milligrams per deciliter. Does the new drug appear to be more effective than the standard treatment in lowering cholesterol? Give appropriate statistical evidence to support your conclusion. So, we're going to have to do the whole thing. Okay? The hypotheses, check the conditions, everything. So, it doesn't matter whether you start with the hypotheses or the conditions. Anyone have a... Start with the hypothesis? All right. So we're going to set H sub naught to be that there is no difference. So mu sub n minus mu sub s for the standard is equal to 0 versus our alternative hypothesis that mu sub n minus mu sub s is greater than 0. And then you have to say what those things are. Where mu sub n is the mean decrease in cholesterol levels of patients who take the new medication and mu sub s is the mean decrease in cholesterol level for patients who take the standard medication. If you want to be complete on this, you probably should add that all patients started with a cholesterol level between 250 milligrams per deciliter and 300 milligrams per deciliter. And the reason for that is that you can't just say, well, this lowers everybody's cholesterol. Well, maybe it works on this group, but maybe once you get past 300, it's not as effective. Okay, or perhaps if you have someone who has normal cholesterol levels, that this is not effective. Hello. So, because we don't have anything better to do, we'll set alpha equal to 0.05. That's sort of the standard alpha level. Okay, at some point we're going to have to check the conditions. Everybody's favorite thing. So,
It's random.
Well, is it a sample?
It's an experiment.
Oh, it's an experiment.
It's an experiment
Random assignment.
of,
Treatment.
yeah, this is an experiment with random assignment of treatment. So because it's a treatment with random assignment of treatment, it's an experiment with random assignment of treatment, then you know you have two independent groups. So our independence part is taken care of. And we also need to know that we're going to have a sampling distribution that's nearly normal. How do we know that that's going to happen in this case? Now,
Not either.
we can't look at a histogram because we don't have the raw data. Okay? But remember, once you get above 30, that we can assume that our sampling distributions are going to be nearly normal. Since both groups contain more than 30 subjects. We can assume that our sampling distributions are nearly normal. And that should be everything that we need. So what sort of test are we going to do?
Two-sample t-test.
Yep. So using a two-sample t-test, and I've started just writing it out this way, mu sub n minus mu sub s, so that it's the populations, and you've already defined what both of those are. We find so everybody know where that is? Stat tests.
Freedom.
So what do you find for the degrees of freedom?
That's 49.
Which makes sense. It's one less than the number in the sample. And t,
Negative 3.92. Did I do that one?
I think I have positive. It doesn't really matter.
Okay. That's 'cause I did.
I've got 3.92, and do you have that p is 8.836 times 10 to the negative fifth?
Let me see. I made it go away. 0.0682. Oh wait, mine's different. I did something wrong.
Did you do it backwards?
I don't know. Good question. I'm doing a z-test now. That's why.
That would be part of it.
There we go. Now we have an error.
So can I get anyone to corroborate my numbers?
My P was 1.76 times to the negative 4.
Did you have a t-value of 3.92?
Yes, but negative.
Did you
My degrees
do...
of freedom is different, so I don't know.
Your degrees of freedom is different?
Yeah, hold on. I'm looking.
Did you do less than or greater than for? I still get negative.
I put that they were not equal.
No, you don't want that they're not equal.
You want that it's greater than.
Right. So it says, does the new drug appear to be more effective? So we want mu sub n to be bigger than mu sub s.
I got 85.37 for my degrees of freedom.
I did too.
Oh, I have that written down right here. Where did I get
But
49?
now
Oh,
my P
I listened to
is
someone else.
499.
Yeah, my P is 8.83566 times e to the negative 5.
Mine's 0.999.
Did you do? You probably did it the other way. If you change it to, because in the problem, the first one that they list is the mean s and not the n.
Facts. Wait, what?
So the 10 and 8 is for s,
Oh, so
and the 18 and 12 is n.
I didn't
Yeah.
know that it mattered.
Because, I mean, 1 minus 8.8356 times e to the negative 5 is going to be 0.999.
So you have to do 18 and 12 first.
Or you can just
Or you can
change
just
it to
switch
less than, yeah.
less than. You make mean 1 is less than mean 2.
That makes sense.
It all works out.
I got it now.
So we agree that 85.371 degrees of freedom
Yes.
and that T is 3.92,
Yes.
Yes.
and we're not in agreement on the number.
Now we are.
Yeah.
Okay.
I thought. Wait, why is the degrees of freedom 85?
So the degrees of freedom, when you have two separate ones like this, is not the number in your sample minus 1. That's only when you have one sample. When you have two sample, the degrees of freedom gets squirrely. Well, I mean, I still can't make it make sense in my head why the degrees of freedom would be a decimal.
How do you have half of a degree of freedom?
I don't know.
What is a degree of freedom?
That's an excellent question that I don't have a good answer for, unfortunately.
How free we though?
There's lots of degrees of freedom.
All we know is we have 85 plus 3 of them.
Can you put your finger on your schedule by chance, the one that you wrote?
Yeah.
I was making the whole packet for people.
We almost have a 90-degree angle. You know.
Alright, then I'll bring it back.
Oh, wait, that's not it.
Yeah, you did this, done the same thing I've done. So perfect. I'll bring it back. Thank you.
Okay.
Trying to find a good stopping point. Don't worry.
No worries.
Sorry, that was a long one.
I had a long one.
So what do we do?
We panic when we reject the null.
So we reject the null.
That is much lower than
So sad.
Actually, it's good news in this case.
We have better medicine.
But the null
Oh
has
wow.
been rejected.
It's the
feelings.
Nulls don't have
No, it's not a
feelings.
hoe anymore,
I don't know
actually.
that.
Yeah,
Are you
it
a
is
null?
hoe anymore still. A null.
So there is convincing evidence to conclude that the new drug
Works wonders.
It's more effective.
No, works wonders.
is more effective.
That's the proper terminology.
If I put that on my test, will they count it right?
Pardon?
If I put that.
Oh, that it works wonders?
Yeah.
They probably wouldn't. And again, this is where you can just kind of pair it. What did they ask?
Stupid.
It's more effective than the standard treatment. In lowering mean cholesterol level. Okay? All right.
There's a party in my tummy.
That little dude, the arm, no.
The green guy?
Yeah, it's like weird.
He's very hairy. I don't like it.
No, I think he's pretty
He's shaggy.
Dude, he's better than the other dude who has like warts all over him.
Yeah. Or the pink lady that's just like a pear.
Hey, I like the pear. Oh wait, no, I don't. That's
She's just like a, it's
that's
like
the
a ball with a head.
Wait, the flower one or the blue one?
The flower one.
I like the flower one.
Isn't it like just like a ball with a head on it, basically?
Okay, one dude is literally like a personified traffic cone that has a skin disease, so I'm pretty sure it could be
Isn't that the
worse.
guy that like leads the show? He's the traffic cone.
Is his name Gabo?
No,
No, that was
his name is,
racist.
like,
that was.
he's
orange.
He wears orange.
So, moving on. Let's do this one because it's a confidence interval, so it's slightly different, but not hugely so. So, yeah.
There was one on homework and the title was Sue Me. I can't remember my name.
Some of the titles are pretty fun. All right.
Diabetes. Again.
It came back. Return of the diabetes.
So here we have resting pulse rates for a random sample of 26 smokers, had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among 32 randomly chosen non-smokers, the mean was 74 beats per minute and the standard deviation was 6 beats per minute. Nice thing here, both sets of data were unimodal, roughly symmetric, and without outliers. So we don't have to look at the nearly normal.
Thank you, problem.
Thanks, problem.
Is there statistically significant? If so, how big? So the first part is asking you to make a decision. And as near as I can tell, although your book sometimes will say use a confidence interval to make a decision, as near as I can figure out from the videos that I've watched on AP Central is that when they ask you to make a decision, you need to do a test, not an interval. Okay? I feel the same way because I like the interval because it tells me both, whether or not whatever it is they're saying it is it within my confidence interval, and it tells me about how big this whole thing is.
Down with College Board.
Down with College Board.
So we will do both for this.
No.
Why? Down with Mr. Davis.
Because this first part asks you to make a decision.
Well, we can make a decision with the confidence interval.
We're big girls and gals.
Oh.
So
Girls and gals. I mean, my man.
H naught is mu sub s minus mu sub n is equal to 0. Or if you want to say that they're equal to each other, that's fine also.
I like that better,
Yeah.
but then it tricks me into making it confidence.
Is.
Versus the alternative hypothesis.
That makes sense.
Mu.
Now notice this just says of a difference.
Does not
Not
equal.
So it doesn't.
So mu sub n minus mu sub s minus mu sub n not equal to 0. And in the interest of time for today, because I'd like to get at least partly to another one, I'm not going to take the time to write out what those stand for.
Let's go plan.
Good job.
We should do that on the test
I agree.
and homework and everything.
And we're going to let alpha be 0.05. So do your t-test. That's the backup thing for the Amazon Prime guy.
Oh God.
They're gonna hit
They
someone.
just hit a curve, I think. I think that was just this one. Been much more exciting.
I got that the degrees of freedom, check me on this please, was
that sounds
close to
alright.
56.
Sounds about right.
I agree. I concur.
That t was 4.154.
That is exactly right.
And that our p-value is 1.129 times 10 to the negative fourth,
I don't want z-test. I want t-test.
which is certainly less than 0.05.
Therefore,
So we reject the null. There
I got
is,
56 for the degrees of freedom. So,
cool. Did you get the other numbers the same?
yes.
Excellent, thank you.
DF.
I think my calculator just died.
oh no. That was tragic.
So there's statistically significant evidence to conclude that the mean beats per minute for smokers is greater than and the reason I know that it's greater than is because I got a t-value that's positive. That of non-smokers. What I really want to get to on this one is the confidence interval. So see if you can do the confidence interval for this.
Calculator, please. Sorry.
It's okay.
Mine
It's dead.
So is it just as a battery?
It just died. Oh,
So,
Can we plug it in
It
for a
just-
little bit?
came back to life. Do you have a charger?
Yeah.
Yes, please.
that's so nice of them. It takes the data from the t-test and puts it in the t-interval.
Yes. Isn't that nice?
They're so kind. Should we do a 93.4% confidence interval just for fun? Because they don't tell us to.
So typically we'd do a 95% confidence
Oh,
interval.
94. I'm gonna do 94.
So at a 95% confidence interval, I guess it should say confidence level. No.
95, sorry.
Why not?
So then we are 95% confident. Is that not what you got?
Three numbers, right? That's a z interval, not a t interval.
We're 95% confident that the true mean difference in heart rate and again I would use smokers minus non-smokers
Well, that's not really good.
is between 3.1 and 8.9 beats per minute.
So on the top you say, yes, there's significant evidence because we rejected the null.
Right.
And then after that you give the confidence interval and you
To say how big.
said that the difference lies in there.
Right. Which is also why if you have a confidence interval, you can make a conclusion and say, well, 0 is not in my interval, so there is a difference.
So there's really no need for step 1.
That's a good call.
Yeah.
In that case.
And actually, I talked to Mr. Hedstrom about that, and he said many statisticians believe that also. In fact, at least at one statistics workshop he went to, they recommended if you're going to do one or the other, do a confidence interval because it tells you more.
Information.
Right.
So downfall. Basically.
All right. We will not get to anything else. The only difference is with these is that you've got the numbers, so you got to do something with them.
Numbers.
Who does that?
So
Don't
you,
get numbers with the other ones.
well, you've got data, so you're going to have to make histograms.
Oh no. My favorite.
All right.